Hello guys, welcome back. In this video, let us analyze which type of query. In this video, let us analyze much more detail about DynamoDB queries. That is, if you do which type of query, then how much it costs you. That is based on the data or based on the read capacity units that this DynamoDB consume while reading your data. So that amount of money will be charged on head of you. So in real time, in practical, so it is even needed, right, for you to minimize that cost? Yes. So let's analyze that in today's video. And in today's video, I also tell you one more interesting thing, that is actually when do we use this DynamoDB? In order to store some data, right? Yes, some non-relational data, some NoSQL data, we use this DynamoDB to store. Let's say you have some scoreboard, like some scoreboard. Let's say you have some application where it contains some scoreboard. Now, in order to store that data, you can use this DynamoDB. So that's what the real-time scenario now I am showing you. And in this case, what happened is, let's say if you are getting very low performance, that is the response takes a lot of time to provide you the particular result. Let's say I created one DynamoDB table. Now I'll show you what is the data present in it. Now you can see I'm clicking on explore table items. In this, you can see you have multiple details like player name, game time, and game and score. So like that, I have some data. Now, what I'm expecting is, I'm expecting to query some data. I'm expecting to get the result of top score persons. So who are the persons get the highest score that I want to query. So if I query that, it takes me a lot of time. You can see I'm just moving on with the scan option in order to query. So I'm scanning the whole table. Now I'm running this. You can say I'm clicking on run. Yeah, I got this response. Let's say I want to scan my whole data and I want to apply some filter. Like I want to apply some filter, like I want to add, let's say I just want who are the players played at this timestamp, or else who are the players are playing this game. Now I'm just pasting that game as the attribute name, and I'm copying one game name and I'm pasting that value here. So in the filters, I'm pasting some attribute name and I placed some value. So if I add this filter, then what happens is this scan command will scan whole data table, whole data, and then it provides me the match which matches with the filter. Now I'm just running this. You can see it is running. So after the process is done, you got some result, right? Yeah. So based on the filter that you provided, you got some result. So let's say I want, I want, I want to filter it again. So in this game also, I want the players. I want the players who got score which is greater than or equals to this score. So I want my score to be greater than or equals to that. So I'm pasting that score as attribute and applying another filter. Now I'm running it again. Now you can see it is running. We get the response of players which are playing this game and who got a score which is greater than this. You can see currently it is running and fetching the data. So within a few seconds or minutes, it will provide you the response. Now currently, how I'm filtering? I'm filtering based on game and score, right? So if I'm filtering like this, then it is taking some time, right? Yes. So, but in real time, this delay won't be accepted by the customers. Customers like to, or users like fast responses, right? Than this type of delay. Since I'm having a lot of data, obviously, if many users or many customers are using your game, playing your game, then obviously it might create a lot of amount of data in your database. So that's why it obviously take a lot of time to process that lot of data. Now, whatever you require is you actually need to implement certain algorithm, or you actually need to use something in this DynamoDB in order to provide the response faster. In order to get the response faster, you need to do something. So what is that? That we're gonna discuss now. So let's wait till we get the response. Now you can see it was completed. The running was completed and I got a response that is, you can see it consumes a read capacity units. How much? 266. That is a lot. And even it doesn't provide me any response. I think no match is found like that. So that's why I'm not getting any response. If I run with a reduced value of score, then may we get some responses. That is maybe some users score this much or greater than this. So I think their scores may be get now. Again, you can observe it was taking me a lot of time. So if you use scan option, then what happens is it actually scans your whole data. Then after, based on if you provide these filters, based on these filters, that that scanned result will be again filtered and produced as output to you. So that's why here the whole data is scanned. If you use this scan option, then it obviously take you much more time. It will be very time consuming process if you use this scan option. I'm just passing it. After I got the response, then I will again restart it because it may some more time. So that's why I'm passing this. You can see the running was stopped. That is the running was finished. And now also same. That is 266 read capacity units are consumed. So we will be charged for that much amount of read capacity units. Now, what actually we think? We think to reduce the cost, right? Yes. So in order to reduce the cost and improve your performance, get the response quickly. I'm just removing these filters. You can use this query option. Actually, you use this query option to make a response faster. Then here you provide some player name. I'm just scanning it to get the whole data again. And I'm expecting to copy one name. Now inside your query, I'm providing the player name. So I want details regarding to particular player. So that's why I'm providing that particular player name. And I'm expecting to run this to get the result of that particular player. So let's see, you can see it returns only 50. That is 50 items it was returned. That means it takes me very less time to provide this response. So here, if you use this query option, then what happens is your query will be executed that is based on the partition key you provided, based on the player name or partition key that we provided. So based on that, it first filters the data. It first identifies this partition key, and so in that partition key, if there any filters are there, then that will be applied. So let's say I want to provide the game name. I just copied the game and I added a filter that is a game. And I also adding the game name as one of the game name which is present. I just pasted that. Now I'm running this query again. Now you can see it was a we get the response. So these many times that person played that game. So this is a random data, so that's why I'm getting these many times. You can see we also have multiple columns, multiple data values, because we loaded that much amount of data. So but actually if you use this query option, then it consumes a very less amount of read capacity units. So that's why, since a less amount of read capacity units are taken, if you use this query option other than this scan option, you will be charged less. Even you get the response quick, that is faster in this query option based on the partition that you provided, based on the partition key that you provided. So let's say I want to show you the detailed. So let's say for you, for now, if you want to analyze as a AWS user or as a AWS administrator, you understood how to do it by using this console. But actually in real time, what happens? Users will just click on some icon, right? Yes. That icon need to provide the response, right? Yes. So how we can do that? So for that, we actually implement some programmatic code, right? At back end, we actually write some code. So let us see that. Let us do that by using code. So for that, I'm just moving on with the Cloud9. You can see, so to show that how to implement this processing using programmatically, I already created an environment for you. Now I'm opening that environment and I'm expecting to show you or query my data from here. From here, I'm expecting to query the data present in my DynamoDB. So with a different possible queries, like you can see, we have seen two types. That is, one is by using query and a scan operation. I will show you one more operation now. For that, I'm opening one new terminal and I'm closing this welcome page. I want to see where I am. So present working directory is this. Now I'm expecting to create some virtual environment. So at first, I want to see whether I am having Python is not present or not. You can see I got the version, so I think Python is there. So by using Python, I am expecting to create some virtual environment. So I used this venv command and m for make that virtual environment with a name virtual env. So by using this name, I am creating a virtual environment. So you can see, you can observe here. Yeah, I need to write this make m should be previous to that virtual environment. Python make virtual environment with this name. I'm just clicking on enter. You can see till now, previously I don't have this virtual environment. Now only just created. You can see that is this. So these many files are created, right? Yeah. Now I list and see. You can see my virtual environment is there, as well as a readme file is also there. Now I want to activate this virtual environment. In order to install in order to install all my packages or libraries inside this virtual environment, I'm activating this virtual environment. So by using source command in the virtual environment, I have bin folder. You can say I'll show you that. Yeah, this is the bin folder. In this bin, you have activate file. By using that, actually you can activate. You can see we just now activated that virtual environment. You can confirm that from here. Not only virtual env, you can even provide any name to this virtual environment. Basically, you use this virtual environment to install all the required packages or all the required libraries that you want for your application. So currently, I want to interact with the DynamoDB, right? So I require Boto 3, right? Yeah. To perform this, that is to perform different types of queries, I have already written some Python scripts and written and saved those scripts in some GitHub repository. Now I'm using that link to clone all those codes to here by using this git clone command. Now you can see it is cloning into this. Now DynamoDB test is downloaded, and inside this I have some files. You can see. So what are the Python scripts that I want to run? Those are also installed now inside it. Now in order to run those and see the response, I'm just moving into them. That is a change directory to DynamoDB -test. You can see I just moved into that DynamoDB test. Now first I want to install these requirements, right? In order to run the code which is present in these files, I need to install what are the requirements I have. So for that, I'm just writing the command to install the requirements. I'm using the pip install requirements, that is R, which is those requirements I already provided in requirements.txt. So that's why I'm providing that name. So now whatever the requirements, that is a table and Boto 3 was installed. Installing. You can see those all installed successfully. Now I want to clear this. So to make it clear, I just written a clear command so that it will be cleared. I'm again writing a clear command so that, yeah. Now we are in this. So now I'll tell you programmatically, how do you actually you implement this scan command and query command. So first let us see this scan. You can see this is the code that I have written. So here you just focus on this main session. So whenever your program starts, it just takes the table name and seconds and max records to print, and it just registers these functions. Then it reaches to the main session if name is main. Yeah. So from here your execution starts. Actually by using Boto 3, it will connect to your DynamoDB, and whatever the table that you mentioned, to that table it actually connects. So since I am mentioned the table name as this player score, it will connect to that table. Now I just taking that time. Actually what I'm doing, I'm expecting to query the data, right? Yes. So I'm expecting to query that data. So for that, I'm using this scan command, but I'm using this scan command. So by using this only, I'm actually scanning my data, right? Yeah, I'm actually scanning my data. Here, I provided my attribute as a badge. If badge is this, then I'm getting the response and I'm just getting the response. That's it. And printing that response by using these two functions. And at last, I'm also calculating the end time. So for executing these commands, so how much time I I am taking. So that I am calculating by using end time minus a start time. So actually start time I calculated previously before this execution got started, the scanning got started. So at last I'm finding this duration and I'm printing that duration. So for printing, I'm using this function to print all items, duration and total consumed capacity. So that request will reach to here. So here actually printing happened. Now I'm expecting to run this scan query. So programmatically, I want to run this scan query. So for that, I want to see, you can see the files are available here. Now I want to run, so which I want to run this, right? So player score scan query. So I'm just copying this and writing a Python space. I'm just pasting the file name. I'm just clicking on enter. Now you can see how much capacity, how much read capacity does it consume. You can see 220 read capacity units this scan query will actually consume. Now let's say I want to reduce this. I want to reduce the reading capacity by providing any partitioning key. So you can do that by using query command. By using query command, you can able to do that. So you can see I have written code for that as well. So Python score query, in this file I have actually written that code. It is same as previous, but the only change here is in the main session, you can see I used query command, right? I used query command. And in this query command, I provided the player name as James Smith, right? Some player name that I provided. This is nothing but partition key. This player name is nothing but partition key that I define whenever I'm creating my DynamoDB table. So now we are using that partition key in order to partition my whole data to query or to scan only a bit amount of data other than scanning whole amount of data. So in order to verify that, so how much amount of read capacity units does it taking? I'm just expecting to run that Python code. So by using Python, so I'm just taking the above and score query. Now I'm running this. You can see, you can observe this. That is, it just consumed 28. What is that? 28 read capacity units. If you scan your whole table data, actually it requires 220 read capacity units. But now, since we are using query option, since we are using query command other than scan command, by providing some partition key, we just used read capacity units of 28.5. So obviously, since less amount of read capacity units are used, you will be charged less, right? Yeah. So that's what happened here in real time. So in this way, by using this query command, you can able to reduce the cost. Let's say I want to reduce the cost again further. I want to reduce the cost. So for that, programmatically you can do it by using get item command. For that also I have written the Python script. You can see the script is the same, but in main session you have to observe this. I have provided get item command. In this I provided my partition key and sorting key as well. You can observe two things, partition key and sorting key, both I provided. So based on these two filters, since I applied these two, since I provided these two as my partition and sort keys, it takes even very less time. So first, based on the partition key, it will get the data. So among player names, it just find this name. So based on this name, the person's columns it will find. So after finding that column also, it will get the data based on this timestamp. So based on this timestamps, it will scan only that particular data and you will be charged for only that. So now let's run this query as well and let's see how much read capacity units does it takes. So for that, I'm just running this Python code to show you that. So get item. So actually this is the Python file name. Yeah. So I'm just clicking on enter. Now you can see the read capacity unit consumed will be 0.5. So eventually very less, right? Yes. So very less. So in real time, while implementing your application, so in order to query your DynamoDB tables, you can use this get item command. You can use this get item command because it consumes only less read capacity unit, so you will be charged very less. So based on the read capacity units that it consume, your application consume, you will be charged for this DynamoDB. So you need to consider this get item command. Let's say I want to process faster. I want to provide high performance by using this query command itself. So can I able to do that, sir? The answer for that is yes, you can able to do that. So how can I able to do that, sir? So by providing some more sort keys, some more partition keys and sort keys. So how can we provide, sir? You can include the indexes by using global secondary indexes option. So I'll show you that. So this is my table, right? I'm just going to view my table. You can see I'm viewing my table. Here I have indexes. So by providing indexes here, you can able to sort your data again. Further, you can able to sort your data and query that data some more faster way. Let's say I want to create an index. Now I'm just clicking on create index. Here I'm expecting to provide my partition key and sort partition key. I'm expecting to sort based on, I want to partition based on badge. So I provided badge as my partition key and I want to sort based on game. I have multiple games, right? I want to sort based on game. And now I'm just clicking on create index. At bottom, you have an option to create index. Now I'm just clicking on create index. Now you can see it successfully submitted the request. Currently it is in creating state. So after some time it will be created. Now just wait for that. It was now active. You can see this was now active. So currently whatever the index that we created, it is now active. Now I want to execute the code. So I want to run the code and show you how much time it requires. So for that also I have written some query code. You can see Python query code. So this is also same as previous, but the only change here is in the main session, I am using this thing. You can see I'm just querying. So nothing I have done. So previously how the query was like that only, now as well. I'm using the badge as key, and when badge equals to camps, I want to query the data and get the response. So for that, I'm just expecting to execute. So that's why I came to bash command shell. Now I'm expecting to execute that. So for that, I'm writing the again Python query run Python space file name. So what is the file name? Index is the, yeah. So now I added. Now you can see even this query function will take me less time, right? Yes. So even you can observe. So this is also query function only. Previously also executed the same, but currently why it reduced the time? So you can see 0.5 read capacity units only taken. So why it takes very less read capacity units? But whereas previously, if you use the query command, it takes me 28.5 read capacity units. Now why it reduced to 0.5? The answer for this is since you included that global secondary indexes. Since you included that, again further partition happens. So in this way, you get the response faster and quicker way than previously. Previously, it takes how much time? 223 milliseconds. Now, only 53 milliseconds. I think more than a half got reduced. So even you got the response, you will provide the performance faster, and you will be charged for less because the read capacity units are reduced, so you will be charged less if you use this indexes like a global secondary indexes. So in real time, if you want to improve the performance by using global secondary indexes, this is the way. Or else if you want to use get item command, then also it consumes less read capacity units and less time. So those two actually we prefer to use in real time. So I hope you understood this video and you got a knowledge on so what is the query that you use in real time applications in order to interact with your DynamoDB to cost less and to get charged less and to provide the performance, to provide the response faster by fast performances. So I hope you understood this video and you got some knowledge or knowledge recap from this video, from this hands-on lab. So thanks for watching. Please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video with another interesting topic. Until then, bye bye guys.